Here, the only value that makes the statement true is positive 1. That's amazing work if you got this one correct. It was tough. First, we'll square both sides of the equation to get 4x squared plus 4x plus 1 equal to 5x plus 4. Next, we want to get a quadratic on one side of the equation and the other side equal to 0. So we can subtract 5x from both sides and subtract 4 from both sides. We'll have 0 on the right and this quadratic on the left. Next, we use factoring by grouping to get 4x plus 3 times x minus 1 equals 0. Once we have our factors of 4x plus 3 and x minus 1, we set each of those equal to 0. Then we can solve for x, so x equals negative 3/4 or x equals positive 1. And like all of our radical equations from before, we need to check each of these solutions in the original equation. When I plug in x equals 1, I get 3 equals 3. So yes, this will be part of our solution set. For x equals negative 3/4, we wind up with a solution that doesn't check. We know 2 times negative 3/4 is negative 3/2 since we can cancel the common factor of 2 in the numerator and denominator. Here, we'll just multiply 5 times negative 3/4 to get negative 15/4. We change 4 into 16/4 so we can add these two fractions together. This gives us a positive 1/4 underneath our radical. We take the radical of the numerator and the denominator to get 1/2, since the square root of 1 is 1 and the square root of 4 is 2. On the left side, I change this improper fraction to a mixed number, negative 1 and 1/2. We know negative 1 and positive 1 sum to 0, so we're left with negative 1/2. These two statements are not true, so we cannot include this as part of our solution set. It's out. This is why our solution set is only positive 1.